welcome to our presentation on the Hello 10 DC Motor Control module. My name is Müge and I'm a product marketing engineer in Desart, and today me and my friend will be hosting this presentation. First, have a quick look at our agenda. We will start with a quick introduction to Hello 10, which includes fully integrated design, Matlab Simulink compatible software called Hello App, and scaling from classroom to industry. Also, demonstration to show you connections, how to download Hello App, and demonstration of PID control. So, the main benefits of the Hello 10 can be listed as fully integrated design, Matlab Simulink compatible software called Hello App, skills from undergraduate labs to industry. Let's quickly see an overview of the hardware of Hello 10, which you can see here. Quick connect interface, which doesn't require any tool, aluminum housing, USB power inputs, inertia disk. As you can see on the top part of Hello 10, there is a toolless quick connect interface, which allows you to use any of the default add-on modules that are provided within the package. Those modules can be listed as the inertia disks for Hello 10, inverted pendulum for Hello 20, and the ball and beam module for the Hello 30. Since Hello is designed not to require any type of tool for switching from one module to the other, swapping between various modules can be performed quickly and easily. Today, we will be working on Hello 10 and its add-on module, inertia disks. Currently on the back panel, USB and power inputs can be seen. You can easily connect Hello 10 to your computer using those input ports and start performing your experiments immediately. Moreover, due to the quality of the aluminum housing, you are getting a high-end product without having to pay a high-end price for it. For any lab budget, the price of Hello 10 is considered ideal. Also, portable module design due to its compactness and smallness makes the user experience very convenient. Now, with the fully integrated design, the Hello 10 can be used as a multi-station, multi-course control lab for the cost of a single conventional workstation. As a result, multiple Hello modules can be present within your lab for all of your students. It can be used with Hello App, which is our software solution. It is a Matlab application that interfaces with Matlab Simulink. You can quickly integrate the module, Matlab application, and educational sources together, regardless of the type of class you will be using the Hello 10 for. It is originally designed for control theory type of classes, but it can be used for other types of applications that you're interested in. Using Hello 10, you can go from basic introductory concepts like modeling and PID control to advanced concepts like LQR and state space models, and etc. As a result, you can cover a full course in control theory with Hello 10 module. Since Hello 10 uses industry standard model, the software Hello App provides an environment which the students are going to encounter often in their career in industry. As a matter of fact, the main positive outcome of using Hello 10 is that the undergrads will be trained to keep up with the professional setting they will encounter after graduation beforehand. As I said before, the standard package of Hello 10 comes with inertia disks, which are quick connect modules. With this module, bachelor's degree students gain basic understanding of control theories such as hardware integration, analysis of system outputs, introduction to control systems with Matlab Simulink, stability analysis, first and second order system analysis, on-off and PI, PD, PID controller design and its effect on the system, system analysis against disturbing effects, obtaining PID parameters according to design criteria by PID tuning over the real system, motor position control. Also, with Hello 20, we will provide an inverted pendulum module, and with Hello 30, a ball and beam module will be added. We provide lab experiments and preliminary experiments. educational sources that translate theoretical content into practice. The aim of the preliminary experiments is to explain the critical points of the control systems course and to demonstrate why they are important. The use of Simulink tools related to the subject is also covered in the preliminary experiments, and the use of tools is shown. After the use of the tools is taught, in the lab experiments, these skills are tested through the real system. Training support is available through the website. Matlab application and educational sources of the module, tutorials about Matlab Simulink basics, and form environment are available through the website. And now, my friend will make a quick demonstration to you.
Hi, I'm Bengsu and I'm an electrical design engineer in Desart. Let's get into our demonstration. After connecting your Hello 10 DC motor control module to your computer as shown, you can continue your experiments on Matlab. Hello 10 hardware has a Matlab application named Hello App. When you open the Matlab, you can access Matlab application from Get Add-ons option. You can download this application when you run a search for Hello App. Before downloading the application, you should add the necessary packages to Simulink. After downloading, you can find the app among the Apps tab. Let's open Hello App. When you open the Hello App, a folder named the Desart Work folder is created in your C drive. After that, the Hello App will use the files inside this folder every time you open the app. In this way, the changes you make in the experiment models are stored in the application. If you want to reach the first version of the models, after opening the Hello app, you can reload all the models by pressing the refresh button. After passing the start screen, we select the language and open the experiment screen. On the experiment screen, we see two big buttons named Setting A and Settings B. If you want to make control applications with the speed data of the motor, we use the A button. If you want to make the control applications with the position data, we use the B button. In this demo, we will control the speed of the motor, so we open the installation model from the A button. We add the serial receive block, which is the communication block that we need to add the opened model. In this block, we make the specified arrangements as mentioned next to step 1 and click the apply button. Another block is automatically added to our model. In this block, we set the baud rate value to 115200. We save and close our model. In the COM port number section that you see on the experiment screen, you enter the port model where the Hello is connected to your computer, and you have selected in the Settings A section. This was 11 for our computer. Then we continue from the Labs tab. As you have seen, there are lab and pre-lab options. The pink button here is the refresh button. You can use this button if you want the models to be converted to their original form. With Lab 1, we can demonstrate a sample experiment model and the use of Hello app. We open the lab model. The model you see is created to control the speed RPM of the motor in Hello 10 module. The box we see as a DC motor plant represents Hello 10. The output of the box is RPM data. After entering the RPM value we want to reach in the reference block, we can create our controller and closed loop system. We can create a P controller using gain block, an I controller using a gain and an integrator block. After entering the desired coefficient for P and I gains, we can open the analysis screen. After entering the time you want to run the model on the screen, you just need to click the Run button. After your model run, you can see the output chart on the analysis screen. But if you want to see a more detailed version of it and compare your different run results, you can open Simulation Data Inspector using this button. As you can see, the output from the most recent run will appear under the tab that was last opened. Here you can choose your signal and examine its values. For different PI parameters, you can run our controller model on Hello 10 and compare the outputs. We will first try Kp value of 0.1 and Ki value of 0.5 and run our model for 5 seconds. Then we will try with Kp value of 0.1 and Ki value of 1 and again run our model for 5 seconds. As you can see, we can examine the results from the Simulation Data Inspector. And lastly, we will run the mode for Kp value of 0.1 and Ki value of 2. As you can see from the plots, the difference in Ki values led to a noticeable effect on our output. For higher Ki values, we can say that the rising time of the output signal is decreasing. With this quick build concept of Hello 10 and Hello app, you can easily examine the basics of control theory. Also, you can report your results and easily share it.